Okay, hi guys. This is just a quick look at my fridge, and this is the power analyzer. I turned the fridge on here at the beginning of the trace, and it must have been running some sort of defrost cycle, and then the compressor has kicked in here. So let's take a quick look at this, because as you can see, there's a big drop in voltage there. Let's zoom in a bit. A bit more. So voltage dropped from about 247 down to about 242.5, just very briefly, only for a few seconds. Let's have a quick look at the current waveform. As you can see, it's got this very distorted current waveform, almost triangular, but with these funny little high frequency components here. Power waveform here, you can see very small reactive component where there's negative power, and power being delivered back to the grid. If I just line these up, you can see there's a little bit of phase lag of the current. Here's this line here is the peak of the current voltage waveform, and the peak current waveform is slightly delayed. Here's the capture, where the current on the top and the voltage on the bottom. This is the triggered an event because of the voltage drop. So this was the current the fridge was drawing before, about 0.6 amps on average, and this is where the instant the motor cut in, the voltage trace. You can actually just see that the voltage has dipped just at the top here. Now the current is quite substantial. We've got 4 amps per division, so it's 1, 2, 3, 4. So peak current of over 16 amps, or in fact about 18 amps here. So RMS current of about 12 amps during the startup phase, and you can actually see it's extremely reactive. The voltage peak is roughly halfway between these two squares, and the current peak is quite substantially delayed. Let's have a look at the current trace. So let's zoom in on this one. Current trace started off about 0.6 amps. Something happened here. I have no idea what this is, because at this point here the compressor was not running, and this is obviously the point at which the compressor cut in. Let's just zoom in a bit on that. See if I can zoom in. Here we go. Big current spike, and initial slight high load on the compressor, so slightly higher current, and then it's just dropped down to a sort of more normal level, and that seems pretty stable all the way down. If one decomposes the currents, or the reactive and the active power, you can see here initially it was purely resistive, purely active power, here at about 160. If I zoom in a bit, actually, oops, you can see here purely resistive power. White is active power. Turquoise here is apparent power, active power, and this is reactive power, and this is just distortion reactive power, so harmonic components, showing fairly typical sort of moderately compensated lagging power factor. Power factor is hovering around 0.78. Oops, let's get that right. So purely resistive load at the top, power factor of 1, drops down to about 0.78 when the compressor starts. And you can see the harmonic content. Here, when the resistive load was running, it was very slightly distorted peculiarly, and I don't know why. There's a peculiar distortion, slightly higher fifth harmonic component. I don't know, I really don't understand why that is the case. And then when the motor starts, you can see very high fifth, third, seventh, sorry, third is red, fifth is orange, seventh is yellow, ninth harmonic, 11th, 13th, 15th, 17th, 19th. All of them pretty severe, particularly the lower harmonics, and you can see, unsurprisingly, total harmonic distortion about 25%. The vector scope, this is rather bizarre. Here's the main fundamental current here, showing the lagging power factor. If it was resistive, it would be on this line. So it's showing about 40 degrees of lag. red is third harmonic, and the phase of that is constantly changing, so it's actually technically not the third harmonic that's coming up, it's actually an interharmonic, and it's probably related to the fact that the compressor is an induction motor and is is slipping compared to the mains frequency, and at the same time the compressor is feeling an uneven resistance. Sorry, the motor is feeling an uneven resistance against the compressor, which, as it's a fairly standard scroll type compressor, you'd expect. So that's probably the reason why this is sort of going round and round and round. And the other harmonics are relatively stable, but bouncing around a little bit. So there we go. The reason I put the fridge on the meter is actually because I think it's broken, because it seems to be using an excessive amount of energy. So I'm going to be metering it for a day or two to see what happens. But there we go. I just thought I'd show you how I was analysing the system spectrum there. I haven't fixed this. It's very untidy. It's not got no units on it. It goes off the scale. But the waveform, I quite like this display. It's quite nice. And yeah, big current surge. And interestingly, you can actually see it takes quite a few cycles for the current to stabilize. Yeah, so quite a big load, probably for about, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 cycles, so about 200 milliseconds. So it's pretty substantial, considering that it's such a relatively small motor. Okay, well, that's all for this video. Have a nice day.